Hello, everybody. Hi. All right. Welcome to Mobile DevCon. I hope everybody's having a fantastic day. I wanted to change pace a little bit. My name is Alan Canestraro. I work at Facebook, and I'm building a product team out here in London. And I want to change pace a little bit from what you've had today. We've spent the day talking to you about all the great things that you can add to your app to make your apps even better than they already are. But what I want to do is take a step back and look inwards and tell you about some of the things that we've done at Facebook to make our apps possible. I've been in app development for 13 years professionally, and 7 on iOS, 7. And I can honestly say that I've never seen any team move from concept to product, shipping product as fast as we do at Facebook. And I want to tell you about some of the things that we've had to change about our development process to make this possible on iOS. So let's get started. First, I'd like to talk about some of the history and how we got here. Then I want to tell you about some of the changes we've had to make from a team organizational structure and from a product cycle in order to get these apps out the door. Then I want to tell you about some of the tools that we use on a day-to-day basis to help develop our apps, to dog food our builds internally, and to make sure that our builds are stable and unit tested. And then I'll tell you a little bit about where I think this is going to take us going forward. So first, let me give you a little bit of history. The Facebook app, version 1.0, launched on the App Store on July 10th, 2008. That was the day the App Store opened. It was one of the first apps on the store, and it's a day I remember very well. And it was a native app, and it was written by one guy. And he went off, and over a course of a couple months, decided he wanted to build something for this new platform. And Facebook was a lot simpler then. So he was able to pull this off in a few months and shipped it out the door. And if you remember, it had most of what Facebook was able to had as a feature set at the time. But as time grew, Facebook grew, and we added a lot more features to our website, to our product, than we could keep up with on the iOS side. And Facebook had to rethink how we did this. So Facebook has a great background in the web. We came from the web, and so we thought it would be natural to, instead of write native code, do things in HTML5, because we could move faster, and we were very familiar with this. And so what we did, Facebook 4, was, for the most part, it was a UI web view hosted in an app that we then sent web content to. And there were a few things that we needed to bridge with the OS, things like image uploading or photo browsing. And for those things, we actually wrote a bridge that we could access via JavaScript using the website. But this had a few problems. Sorry, this actually had a few great advantages. The first being instant updates. And as you probably know, when you make a change on the web, all your customers get it immediately, no exceptions. It also gave us the ability to do things like A/B testing, right? We like data. And at Facebook, with the web, we can try different things, different experiences with different customers, and then see how engagement falls out of that. And it also gave us perhaps the holy grail of multi-platform software development, and that was the ability to have one code base across each and every platform. But HTML had a problem, and it had a few problems. The biggest one was performance, right? Before anybody could see anything when they went to the app, we had to download all the HTML for the page, including the JavaScript, that was the app itself, and all the CSS for layout. And only at that point could we display anything to the user. So our users perceived it as very slow. We didn't have a way of tuning to these multi-core devices that we now all had in our pockets. Also, we had to do a lot of hacks in our HTML to do things, to do DOM manipulation. If you think about our timeline, our news feed, it's an infinite scrolling feed. And in order for us to keep that performant, we needed to be able to remove newsfeed items and place new ones on as they scrolled on and off the screen. And with HTML, it becomes very difficult. And if you know iOS, you know that things like classes like UI table view make that very easy. In fact, they do it for you. It was also very poor for memory management. All our resources ended up getting loaded and kept in memory most of the time. Debugging was very difficult. Getting stack traces, the stack traces were very poor. If you've ever seen a crash inside of a weblog, it doesn't really tell you very much. And we were pretty limited in terms of animation and effects. Even though HTML5 has come a long way over its predecessors, it still was nothing like what we could do with native code. So a few engineers at Facebook decided that they were up for a challenge and they wanted to try and build native again. And the goal was, could they build something that was faster in native than it was with the web? And they had a very high bar. Remember, Facebook had grown significantly over the original versions of the iOS app. We added a ton of features, so these guys had to go and rewrite a lot of the features that we added on the website. And because this was an experiment, these engineers in this room couldn't disrupt the company with something that could potentially not ship. So these engineers moved to a war room. And if you don't know what that means, at Facebook, a war room is a room that's isolated from everyone else with all the computers and all the people that are required to make the project and all the snacks and drink. And occasionally we'd let in some air and some sunlight. But we basically sequestered these engineers to see what they could produce. It was a bit of a winding road. It didn't take just a couple months. It took almost a full year. But it led to some improvements and some challenges. One, we got a chance to rethink how we fetch data from our APIs on the web. Second, we got a chance to experiment with some advanced rendering techniques. We wanted our newsfeed to be very smooth. And in order for us to do that, we had to go deep down to core animation and do some things that were a little advanced. And as much as we didn't want to change anything from our previous version, this was an experiment to prove that we can build the exact same app faster. Designers like to sprinkle in things that make things prettier, and so the animation, if you're familiar with our app, when you can tap on a photo and it flies in, and then you can pinch and it flies back out, that was something that they had to add, and we did. Our engineers had to learn core data and core animation, which are fantastic frameworks, but very advanced and require a lot of time spent on them. So we shipped the app internally to our employees in mid-2012, and our employees liked it, and we decided it was time to get this out the door. So we sent it out to the public in August, and the reaction was very positive. The press loved it, but more importantly, our users loved it. We had about a two times perceived speed increase across the entire app, and our user ratings went way up. So we achieved the goals that we set out for. But now we had to figure out, how do we make this work across the whole company? There was one lesson that we learned very late in the product cycle. We got this product out the door, but a few engineers was not going to cut it. As we were developing Facebook 5, the newsfeed team wanted to come up with a new feed item type called Pages You May Like. That turned out to be very successful. The premise here was that we would suggest some pages to you with some advanced artificial intelligence. And an example of this is if you're from a small town and there's a sports team that a lot of your friends who are also from that town like, chances are pretty high that you're going to like it too, so we suggest that page to you. But the newsfeed team wasn't thinking about the Facebook 5 rewrite. And the Facebook 5 team actually didn't know about the newsfeed edition. But Zuck saw this and insisted that we go out the door. So a second war room was opened up, and this included some of the newsfeed team and some of the iOS team, and they went off and tried to figure out how to make it work, and they did it in a couple weeks. But it wasn't something that we wanted to reproduce. We needed something that was more sustainable. Because we didn't just have the newsfeed team. Facebook is broken up into different products for different features, like timeline and comments. And each of these teams had seen the performance benefits by moving to native code, and they had their own set of features that they wanted to add to the app. And the iOS team was starting to get overwhelmed. It was starting to become way too much for one team to build one app. We didn't just have one app, we had 5. So we restructured things into what I like to call the team sandwich. And the team sandwich has a few different layers. Down at the bottom, we have the core team, and they build the infrastructure that's used by the rest of the products. On top of that are the product teams. Now, the product teams are separate, but they build their product features based on the infrastructure from the core team. And there's another layer on top of that, and that's the release team. The release team's responsibility is to make sure that the product goes out the door stable. And the way we actually structure the release team, there are some dedicated release engineers, but we also have a rotation from each of the teams based on what features make it into the app. So we have a set of people that are just responsible for making sure that the app is stable and on time. And what used to be the iOS team, the dedicated iOS team, now became the core team. They were the most experienced on iOS, and they were the ones that were perfectly positioned to be able to write the infrastructure that would be shared across the rest of the application. And their job is to make sure that the app also stays fast and the code stays clean. So this is great. We were able to restructure our team to move fast. But now we had to think about our product cycle. In most teams, in most projects that you may have worked on, you tend to be feature-driven. You decide that your version 2 of your app is going to include features X, Y, and Z. Well, with the structure that we had with all of these teams, that meant that our releases were at the mercy of the slowest product team. And sometimes features get changed, right? We move quickly, which means we reevaluate frequently. And if a feature wasn't ready to go out the door, but it was scheduled to be part of that release, that means that release would have to get held up, which held back the rest of the features. So we took a note from Mozilla. And it should come as no surprise, actually, several ex-Mozilla employees and executives actually work at Facebook. And so they brought to us something that worked really well for them, and that's something called the fixed release cycle. And the fixed release cycle says, instead of shipping an app based on the features, you ship an app every X weeks, no matter what. And at Facebook, we've experimented with some different times, and we've landed at 4 weeks. And what this 4 weeks breaks down into is we start the 4-week cycle by taking a tag of our master branch. And that tag for the next 4 weeks will be spent stabilizing. In fact, the first 2 to 2.5 weeks are spent fixing bugs and making sure all the features got integrated properly. And the last week and a half is something we call the soak period. And the soak period really ideally is when we don't touch anything. And we want to understand what bugs are there, and sometimes we have to fix ones if they're serious enough. But really, we just want to know that the app is stable and we can catch any last issues. In order for us to do this with these product teams, we require that the product teams build their features with an off switch. And that means if we decide during the release cycle that that feature was not ready, or maybe it destabilizes the build, we turn the feature off and we can try again in the next release. And frankly, the product teams are pretty happy with this because if they're not ready, they don't have to wait 4 to 6 months for their feature to get into the next release. They wait 4 weeks. And the way we do this is we ask them to build them in with pound defines at the very, very least, but ideally using runtime switches. And I'll explain a little bit later about how that becomes even more useful. One place where this saved our butt was the new like bar. If you remember our old version of the app, it's what you see on the left. It has like, comment, and share in little text that you can tap to like, comment, and share. And the design team came up with something that was a lot prettier. In fact, they tried it out on the mobile web first and found that a lot of people were engaging with it much more frequently. So the result then is what you see on the right. And they built it with an off switch. And we had a bug. The bug was that, see those 3 likes, 1 comments right above the like bar? That tells you how many people have previously liked or commented on this post. They weren't able to resize the feed in time. They needed a little more time to make that work. And so Zuck saw this and said, we can't ship like this. This was just a few days before we shipped the version of the app. This was about 2 months ago. And we flipped it off, and pretty much nothing else changed, and we were able to go out the door 3 days later on time. And the next month, they fixed their bug, and we were back to this. Now I want to talk a little bit about the day-to-day. What do engineers do as part of their process? At Facebook, we have something called developer velocity, and that's a metric we use to measure how fast can we go from a concept to a feature that's shipped and in customers' hands. And we like to iterate quickly. And the only way we're able to do this is that while we're stabilizing our release builds, we are also able to experiment on new features. And we have one cardinal rule here, and that's you cannot break master. because there's nothing that slows down a team more than a broken build. In fact, we care about this so much that we went and printed a whole bunch of posters. This is part of the iOS team, printed a whole bunch of posters and put them up around campus to remind people that they should not break master. And in order for us to do this, there's a few things that we had to do to the engineering process to make sure that our master is always solid. First, so engineers make their changes locally, as I'm sure you all do. But instead of checking right into the master branch, we have a little bit of a process in between. Engineers post their changes for review by the rest of the team. When they post their changes, our build bot goes and takes those changes, inserts them into the tree artificially, and then runs them to make sure that there were no build failures and that all the unit tests pass. While that's happening, team members, the rest of the team, can go and review the change and have a discussion about whether the change is right, if other people agree, if there's anything that they need to modify to get this right. And once the team is approved and we can verify that everything passes correctly, then it's time for the engineer to check in his change. Now, I get asked a lot, what source control system does Facebook use? And if you haven't heard this already, we use Git. And Git was designed for Linux, which has thousands of distributed engineers, and I don't know how much source code, but tons of source code. So it's designed to be very fast. And that's perfect for Facebook's code base, because we have a huge code base. But another great feature about Git is it allows you to do nonlinear development. It allows you to have multiple changes at the same time. And if you know other source code management systems like Subversion or CVS, you frequently have to check out an entire version of the branch or check in your changes if you want to try something new. And in Git, each of these is pretty much treated like its own branch that you can jump between. Now, when you check in your changes, when you submit them for review, instead of going into master, it goes into a system called Fabricator. And Fabricator is open source, which means all of you can go download it and use it as part of your process. And what it does is it takes that diff and it creates a web page for every diff. And that web page gives you a few things. One, it gives you the before and after of the source code. It gives you a diff inline on the web page so you can go to one place to see what the change was. And it also gives you a discussion forum where the rest of the team members can talk about the change. And not just one global discussion forum for the diff, but it actually lets you do a line-by-line discussion forum. If somebody really has to say something about line 243, they can go point on that and insert a little discussion. It's pretty cool. So I want to show you what that looks like. This is Fabricator. I'm going to zoom in on the header here, and there's some things to note. The first one is the title, right? So this is my check-in. I'm fixing an accessibility problem with one of our views for visually impaired users. The change needs review. I'm waiting for my team members to take a look at the change. There's the author, there's the reviewers that I've asked to take a look, there's a number of lines, and below that is something that's extremely important, and that's the build status for each of the builds that we're running automatically. And you'll see here on the second line, I broke the build. I broke Facebook for iOS. That's the build. That's the app that you all download. So shame on me. So the next step for me is to go back and fix it, resubmit for review, and hopefully it passes. Not hopefully. I know what I'm doing. So a little bit below that, there's some more things in Fabricator. One, we see the start of the discussion forum down at the bottom. And then below that, something called a test plan. And the test plan is me saying, what is it that I tried to make sure that this change actually works? And then finally, we have the diff. So there's the source code and an example of an inline discussion for a particular line in that diff. And at Facebook, we're sometimes not satisfied by words, or sometimes images can speak a lot more than words. So we have something called image macros that engineers spend way too much time making, but they do. And this was a comment about the diff. In fact, the image macros tend to be so much fun, I thought I'd give you a little helping of them here. So the one in the bottom left tends to get used a fair amount. So, all right, so now manual review is not the only way that we have to check code. We actually have some automated tools as well that go and verify the quality of the code. One tool is called ArcLint, and this is also part of Fabricator, so part of the download for Fabricator is something called Arcanist. And in there, there's a tool called Lint, and what it does is it allows you to set up scripts that will automatically run through the changes at check-in time, run through all the source code, and tell you if there's anything that the script catches. And this is great for things like, I've worked on teams that are very strict about style guidelines, indentation and braces. Those kinds of things are easily scriptable. It can also do things like warn against certain symbols, or it can check for certain pattern mistakes in your code and can even offer to fix them. So I want to show you just a quick example. Here's a block of code. And if you can read this, the first few lines is a method that basically goes and sets an accessibility trait on a view to tell the view that it's a header. The second block is a dealloc, where you release your instance variables. And so when I run this through ArcLint, this gives me a couple warnings. Actually, one warning and one error. First, the warning is about this accessibility trait that I used. And this accessibility trait is only available on iOS 6. And one of our engineers hit this bug several months ago where they used this trait, and on iOS 5 causes a crash. And everybody at Facebook likes to use the latest stuff, so we caught that one, but we would not have caught it if not for this lint rule that checked to make sure that you're about the symbols that you're using. And so as a developer, when I see this error, I know that I should go in and check for iOS 6 if I'm going to make this code, if I'm going to call this code. The second error it caught, and this one is actually an error, the other one was a warning, is that you're never supposed to call dealloc directly on anything except super. And what I probably wanted to do is call release. And the person that wrote the script knew that. And they actually set it up to propose the change for me. So when you have these kinds of changes that propose the correct change, all I have to do then is press yes, hit return, the code gets patched and resubmitted, and all is good. Now, I've seen some pretty creative lint rules. There's actually one in there that's saved my butt a few times, which is if you add yourself as an observer to the notification center, it checks to make sure that you've also removed yourself as an observer, and that's pretty handy. All right, so another tool that we use at Facebook is something called BuildBot. And BuildBot is what we use to check for build failures and unit test failures automatically. And the questions, what it wants to do is basically verify that everything still passes, and then it goes and it updates Fabricator with the results. Now, one of the great things about this, if I was to go and run all 5 of our apps through builds and run all the unit tests for every one of my check-ins, that's going to take me 30 to 40 minutes to run all that stuff. And sometimes you might be working on some piece of code that you think is pretty safe, but you've got some other app that's depending on the behavior that's going to break, or a unit test. Well, this, because it's distributed, will actually give you a result back in about 5 minutes and update Fabricator with the results. And that's all the apps, all the unit tests, 5 minutes, done. And if somehow you're able to circumvent BuildBot and still get your broken change in, you get a BuildBot failure email, and that tells you basically drop what you're doing and go fix your code and resubmit, or else you've broken master. All right, so I want to talk a little bit about how we handle builds at Facebook and how we dog food internally. We have lots of employees at Facebook, and all of them are faithful users of our products, I like to believe. And so there's no better people to be our guinea pigs on our version of the app than our employees. So we deploy to everybody. We deploy to everybody internally. And we do this by signing with the enterprise distribution profile. And if you haven't played with this, I highly recommend you go check it out. It's part of Apple's developer system. And what we do then is we code sign with the enterprise distribution profile, and we post these builds to an internal website. And every morning when our team launches the Facebook app, they get a warning that says, hey, you're running yesterday's build, go and update. They click on OK, they go to our website, they tap the link, and it's installed directly on the device. They don't have to do anything else, and they're always up to date. Another thing we do, this was a neat little trick that I didn't know of before I came to Facebook, which is that we use different bundle IDs for each of our types of build. right? We have our App Store build, which I always like to keep on my device in case there's anything weird with the daily builds. But I also need to have the daily builds on my device to make sure that I'm testing it on a day-to-day basis. And of course, I'm an engineer, so I'm building and I'm installing every few hours new changes that I've made. But sometimes those changes are unstable and I need the other versions side by side. So by tweaking the bundle IDs, you actually get to install multiple versions of your apps side by side. Here's a screenshot from my iPad, and you'll see I actually have 4 different versions of the app installed on my device. And we've actually gone and changed the icon for each. And the bottom right corner there, that's our golden master. That's the one that's about to get shipped to the App Store. So it's got the little gold leaf around the edge, which is kind of a cute little addition. And another thing to notice here is one of our engineers for a hackathon thought it would be really handy to have the build number embedded right into the icon. So if you report a bug and you need to find out what the build number is, you don't have to go into the app, open up settings. And what if you've got a build that's just crashing on launch? You're screwed. There's no way to tell the build number. It's on the icon, really easy to find. Now, as far as branching goes, I've talked a little bit about this. We have 2 branches that run concurrently at all times. One is our master, and master is where all our experiments happen. It's where all our feature development happens. But it's also where all our stabilization happens, because as our release build is running, we check everything in the master first, make sure it works there. And then the release team goes and uses a tool that I'll talk about in a moment called Relief that pulls those changes automatically into the release branch. And so Relief, again, part of Fabricator, open source, just open source about a month ago, I believe. And it's a tool that's specifically meant to manage this workflow. It's meant to merge changes from a master branch into a release branch. And the way it works is, as an engineer, when I've made my change and I submit it to master, I can then go and nominate that change for the release branch. Then the release team that I told you about earlier gets their set of nominations on a dated, as the nominations come in, they make a decision whether they want to take it or not, and press one button, and it automatically gets merged into the build. Here's what Relief looks like. A few things to note. So when the release engineer sees this, they have to make a decision. They have to make a call as to whether this is going to be safe and whether this is going to add to the quality of the release build. And so there's some metrics here that we have. One is the size, which is the top of those 2 bars. And in this case, it's a 10-line diff, right? And you can imagine a 10-line diff is probably has a higher chance of being stable than, say, a 1,000-line diff. So if that bar is nice and full, they may want to do a little more investigation before they pull it in. Below that, there's churn. And churn is not a metric to do with the code itself, but instead, it tells you how much back and forth happened in Fabricator between the engineer and the rest of the team to discuss the validity of that change. You can imagine if the engineer posts his change and it gets rejected and he posts it again and there's 12 comments talking about whether this is the right thing to do, there may be something worth looking at, and this is really easy for the release team to tell that there was that much discussion. On the right here is something that's really interesting. It's called karma, and engineers never get to see their own karma, and it's a discretionary metric that the release team basically gets to give you and take away little stars based on your performance in helping the release team. There's one engineer who, it was about 5 p.m. the day we were going to make the cut for our release branch, rushed in a change and broke the release build, and the release team took away his star. And the next month, he felt really bad about it and worked really hard to help them stabilize, and they gave him his star back. So just like grade school, but sometimes that's how you have to deal with these people. So anyway. All right, so the last thing I want to talk about is how we test the app. Right. So Facebook, we have, I've talked about how we can manage experimentation and stabilization at the same time. But ideally, we don't want to have to spend the time to stabilize. It should always be stable. And so we work towards that goal with some rules that we have in place. So we don't have test engineers, right? Some teams I've worked on in the past, As an engineer, you write the code, you ship it over the wall, and then you have QA go and try things out, and hopefully they find the bugs, and then they send them back to you, and you have to make a decision as to what's going to get fixed or not. We don't have QA departments, and we don't have test engineers. But what is in Facebook's culture is high-quality apps and reliable user experience. And so in order to enforce this, we rely on our engineers to include developer-authored tests. Now, if you're not familiar with unit testing, it was popularized about 10 years ago. It's been around a long time. About 10 years ago, there was a book called Kent Beck called Test-Driven Development. And the idea, the philosophy behind this is that when you write code, you know what your inputs and outputs are going to be. You know what your methods are going to be. And so instead of going and writing that code, you write the tests that verify that code. When you run those tests, it's going to fail because you haven't written the code yet. So then you have a failing test. You go ahead and you write the code, and you iterate the minimum amount of code required to make that test pass. Okay, now you have code that works, but it's not pretty. So you can go and clean up your code. You can go refactor. You do whatever you need to do to make the code pretty and to stabilize. But because you have that test that's passing the whole time, you know that your code is high quality. And what this does is it doesn't just help you test the code that you're writing. It helps you build up a library of tests that will run across your entire code base. And it helps you limit future defects in this way. In fact, it catches problems so early that your code, your bugs, don't even make it into the code base. They never even make it past Fabricator, and your code stays stable throughout your release process. So unit testing on iOS is actually pretty easy. If you haven't played with it, it's just a checkbox in Xcode when you create a new project. And what it does is it uses OCMock and Send Testing Kit. It's well documented. I encourage you to go check it out. It uses the dynamic nature of Objective-C to help you insert these mock objects to pretend that they're the inputs and outputs of your classes. But unit testing on iOS is not ideal. Some of the frameworks are immature. There's no good dependency injection, and UI automation can definitely use some improvement. But more so, iOS engineers, this is just not part of our culture. Unit testing is not something that we learned as we learned iOS. And there's some other problems too. Xcode build, which we rely on very heavily in order to do our continuous integration system. Our build bot relies on Xcode build. Xcode build doesn't know about your test action in Xcode versus your run action, which is what you use as an engineer. So your schemes get kind of dirty. Also, Xcode build, again, part of the iOS SDK, doesn't run the tests that require the simulator. And for us, this is a huge problem. And in true Facebook fashion, we decided to fix this problem. And very, very recently, we wrote a new tool called XCTool. And XCTool is based on Xcode build. In fact, it's syntactically the same. If you're familiar with Xcode build from the command line, it's the same. And it solves the problem of test and run schemes when run from the command line. It also solves the problem of running tests that require the simulator. XCTool will do that. And it gives you structured output. And if you're using Fabricator, we've already done the work to make it look right in Fabricator and give you some pretty output. But because it's structured, you can go and customize it for any other build system you use. If you use Jenkins or TeamCity, those are easy ports from a JSON structured output to whatever those tools take in. In fact, we even made it easier from the command line. If you've ever used Xcode build, if you've ever built from the command line using Xcode, this is what your output looks like, and that's for one file that's successfully built. Well, what we did was we took the output, we made it a lot prettier, and this is what XCTool spits out. Those were successfully compiled files. There's one warning, which is super easy to catch, especially by scripts. And XCTool is available today. We just open sourced it this morning, and the URL is down at the bottom. So if you require unit testing and a continuous integration system, this is the tool you need. Thanks. I didn't write it, but I'll take the applause. All right, so there's some other tools that we have for testing, for internal testing. One of them is something called Rage Shake. And Rage Shake is great. When our employees find a bug, they take their frustration out on their device and they shake it up, and we use the accelerometer to tell it what they're really trying to do is report a bug. And at the time that they shake their device, we collect some things. One, we take a screenshot of what's on the screen. We gather the last 10 seconds of network logging. We get the last crash log. So if you crashed and you relaunch and you give it a shake, we'll actually get that as well. We get the last 10 seconds of NS logs, and we even dump the view hierarchy. And we package all that stuff up, and we send it to Facebook in a task that an engineer gets and knows to go fix. The dump the view hierarchy I want to call out is really, really handy. This is something I used to use a lot. I use a lot. And it's if you call from your GDB debugger, UI application, shared application, current window, recursive description, it'll actually give you this great log of every view that's on the screen. And if you haven't used it, use it, please. Go look it up if you didn't catch what I just said. But it's been great. So another great thing about the Rage Shake, because you're shaking the device and you're not touching the screen, you're not interrupting anything that may change if you have to have some gesture, right? If your view state is really sensitive, the bug is really sensitive to the view state, all that stuff gets captured without touching the screen. Another super handy internal tool that we have for testing is something called internal settings. And if you haven't included something like this in your app, I would definitely go and encourage it. Our debug builds of the app have and our daily builds have an internal settings panel where you can go and turn on and off features, right? If you've built your features in such a way that they have a runtime switch, this is where you can go toggle it on and off. But it also gives you some places to, let's say, change parameters. Let's say you want to tweak some timer or you want to tweak some values. You can do that here without having to rebuild all the time. This is super handy. And we've talked a lot today about deep linking. Well, we deep link a ton in the Facebook app. And so if I were to scroll down a little further in our internal settings, there's basically a little control panel that lets me trigger a whole bunch of URLs so we can make sure that we're deep linking correctly within the app. So that's where we've been. And those are all the changes that we've made at Facebook in order for us to be able to move fast. Right? That's our overarching principle, is that we want to be able to move fast from concept to product. And we've set up new processes, and we've built a ton of tools. And what we've gotten now is something that's way better than we've ever had before on iOS. And now it opens us up to a whole bunch of possibilities. New things that we can do for features, new things that we can do for animations, and the future is bright. And I think all of these things that we've done to make Facebook as nimble as we are make the platform a really exciting place to be. So, thank you. We actually have about 2 minutes, a minute and a half for questions, so maybe we can squeeze one or two in. Please wait for the microphone to come to you, and then we'll see what we got.
Hey, man.
Hi.
Do you do automated functional testing on the app?
Automated function testing?
Functional testing, like scripting?
Oh, so actually, yeah, that's something that we're playing with a lot. More just very recently, there's we use something called WebDriver to help do that. And actually, Simon Stewart, who's speaking next, will be talking about some of that. So I definitely encourage it. But it's something we're ramping up on. Yeah. So.
Hi.
Hi.
So about test-driven development, right? How do you circumvent people that don't cover every bit of code?
Right.
Code coverage.
That's a great question. We've struggled a lot with that. I mean, I talk about the culture. iOS engineers, we're learning, but we tend to not want to write tests. So instead of, we don't have a really good measurement of code coverage right now. But what we're trying to do is get any bugs that are reported to have a test associated with them. So at least going forward, we can verify those kinds of things. Also, for new code, we have a kind of a policy in place that says about 50% of your check-ins should have unit testing. So it's not a strict metric about code coverage, and I wish we had a good way to do that, but it's definitely something we need to work on. Yeah. 1 minute, yeah.
Hi there, Keith Moon, BBC News.
Oh,
Hello.
hi.
You mentioned that it took about a year to build the first iteration of the native Facebook on iOS.
Right.
How big was the team, or sort of roughly how big was the team that built that?
That's a good question. I actually don't know the answer to that. I think it was about 6, but I don't really know.
Thanks.
Yeah.
Hi, Dan Thorpe from Badu.
Hi.
With so many branches and builds, how do you deal with merging the Xcode project?
That's a good question. So we definitely have merge conflicts with the Xcode project, and we just deal with those on a case-by-case basis. Generally, Xcode, the kinds of conflicts that we tend to hit are somebody added a file, somebody else added a file. Those tend to merge pretty easily. In more complex cases, we'll just go and replay the changes on top of it. So we'll check it out. I don't have a good answer for that. So that's it. Thank you very much, everybody. Look forward to meeting you all later today.
Yeah. All right. Thank you, Alan. Awesome. So James already mentioned it in this morning's keynote, but we have Pars with us. So the next presentation here is going to be from Hector, who is going to dive into Pars's features, while in the other room we have Simon Stewart, who will be talking about how Facebook built Facebook for Android in 10 minutes.
All I gotta do is call, diving deeper. Would you get me out of this despair? Though I've been trying to lose it all before it's gone. Whatever comes, a high can smile if it's filled with tears. I've been waiting. All I gotta do is call, diving deeper. Would you get me out of this despair? Holding on together, I try to set the night on fire. Holding on together, I try to set the night on fire. Holding on together, I try to set the night on fire. Holding on together, I try to set the night on fire. Holding on together, I try to set the night on fire. Holding on together, whatever comes, I can smile if it's filled with tears. I've been waiting. All I gotta do is call. Diving deeper. Would you get me out of this despair? Holding on together. Try to set the night on fire. Holding on together. Try to set the night on fire.
Hello. I'm Hector Ramos from Pars. I'm the solutions architect at Pars. So first, I just want to ask, how many of you have used Pars before or have heard of Pars? Awesome. Almost 50%. So today I'm going to give you a brief overview of what Pars is and what it can do for you. So first, in the last few years, we've seen these many mobile apps coming up. Everybody wants to build their own app. But the problem is that building apps is very hard. You have to set up servers, configure, deploy those servers, set up the backend. And you're basically on your own when you're setting up the servers. So what if you could just have a service that let you do that very easily? First, let me talk a little about what you need to do in order to set up your own backend when working on your mobile app. First, you need a database. You need some way of storing that data. You need to share data between devices, between users, and synchronize that data. Then, you need a REST API. That API basically sets up all the endpoints that will let you get that data, save that data, and so on. Then you need to actually set up the servers. Those servers will hold all the will manage user accounts, user authentication, keep the user session, and also manage security, control access to your data. And we haven't even gotten to your app yet. Then you need to manage networking. You need to talk to those servers. It's not easy to set up. But mobile apps don't always have a network. So you might want to implement caching of that data so that that data is available even if the device is offline. After you have done all of this, that's when you get to the fun stuff. And I'm pretty sure almost everybody here would agree that you would prefer to work just on the fun stuff, right? So let me show you how Pars will help you just work on the fun stuff and what makes your app unique. So I think that a good way of explaining this is to use an app as an example, an app that everybody knows, so that you can see how Pars would work in that scenario. So I can think of one app that's complex, has lots of data, files, user accounts, and so on. So I'm going to use Instagram as an example. Instagram, as you might know, is a photo sharing app, and it has users. It integrates with Facebook and Twitter. It has comments and likes that you can leave on photos. You can also track the user's location. They can associate a location with that photo. And of course, Instagram has to store those photos in some manner. Once you have all of this, you need a way of get that data and display it. You also have to model a relationship between users so that you know which users are following which users. Finally, you can use, Instagram uses push notifications to keep people coming back to the app. That way they can know if someone left a comment on their photo or if someone liked their photo. So let's go through all these pieces and show you how you can do this with Pars. So first, users. If you were to implement users in your own backend, you might start by creating a user class. And that user class might have a username field, a password field, and you will need a way of signing up that user in a way where you can make sure that the usernames are not repeated, there's no collisions between emails, so you need to make sure those users are unique. So let me show you how Pars takes care of that for you. So first, and this is an iOS example, we have native SDKs for all the platforms. So on iOS, you basically create a PF user object, you set that username and that password, and then you call sign up, and that's it. That's going to talk to Pars servers asynchronously. In the background, it's not going to block your UI thread, and basically it's going to return a block saying this user signed up, and this is the user session. in addition to signing up a user, you need to be able to log in as that user, given a username and a password. Parse will also make sure that that username and password, of course, are a good match for a user. So you'll get that, in that block, you'll get the user session back. So once the user has logged in into your app, you need a way of knowing which user is using your app. So the way you get that is through the current user method on PF user. So with that out of the way, what about sharing stuff to Facebook? If you wanted to share content from your app to Facebook using the Graph API, you will need to first get the user's permission to talk to Facebook. So you will need a way of linking that user we just saw to their Facebook account. So what Parse provides is a Facebook utility where you basically give it a user, in this case, the current user that's logged in, and you just specify which permissions you're asking for. If you, by default, if you don't pass any permissions, it's just going to get the user's public profile, their picture, name, email. But you can pass any other permissions that you need. And this is basically going to use the Facebook SDK to get those permissions from the user. But this is just to link an existing user to Facebook. What if you wanted to log in with Facebook and you don't care if there's already an account for that user? So the login method will actually check if there's already a user linked to that Facebook account. And if there's none, it will just create a new user already linked to Facebook. And what this means is that you already have a user with permissions to use the Graph API, so you can just get whatever data you need from the profile. And the great thing is that this also works for Twitter. It also works with the Twitter API. There's a method that you can use to sign your HTTP request to Twitter so that you can get that data back. So with that out of the way, we need to talk about data, comments and likes on photos in our example. So the way that Parse allows you to save custom data to your backend is through the PF object. A PF object, you basically initialize it with a class name. The class name, you can think of it as a table name. And it works very similarly to how an NS dictionary works on iOS. You can set any sort of field on that object. I'm setting the current user in this case. And then I just save. That takes care of networking, talking to Parse, saving the object, and bringing back that unique ID for that object. And this is how it looks in the data browser at parse.com. So you can see all the fields we set up on that object. So next, we need a way of tracking the user's location easily. You might think that a good way of doing this is to just use PF object and set a number for the latitude and the longitude. And that could work. The problem with that is that if you want to actually query based on distance between two objects, then you need to implement that math to check the distance between two objects. So what we do with Parse is that we provide a GeoPoint native object, which you can initialize with a latitude and longitude, and you can set it on an object just like you would any other string or number. And you save the object. Here you can see it's saved as a GeoPoint native object in your data browser, all ready to be queried. So you can actually get objects around a location given that field. Next, we need to be able to save photos. Of course, that's the main use of Instagram, saving photos and having them become available to other users. So in a similar manner to PF GeoPoint, we have the PF file construct. Basically, you give it an NS data on iOS, which is a package of bytes, and you save it just like you would any other value on that PF object. And as you can see here, once I create that PF file based on that NS data object, I'm saving it before I even save the object that contains it. The reason I'm doing that is because that's going to actually kick off that upload immediately. This is great for user experience. Let's say, for example, in the case of Instagram, if you're taking a photo, you might want to start uploading that photo right away, and then once the user actually types the caption or adds the filter and hits publish, that's when you save the object. And the data is already there. You don't need to wait for that upload to finish. And here you can see, you get a file column on your data browser. And that file, you can click it. You can see whatever content that file has. And on iOS, you can get the full URL to that file if you want to share it elsewhere as well. So I've mentioned the data browser a couple of times already. So this is the data browser. When you log into your parse.com developer account, you have access to all the classes. You can see which columns each class has. You can add objects, delete objects, and you can even filter those objects to manage your data. So going back to Instagram, we talked about users, Facebook and Twitter, comments and likes, location, and pictures. But we still need a way of getting that data back and actually displaying it in our app. So the way you do that with Parse is through queries. Queries are a very nice abstraction which allow you to just say, hey, I want to get pictures, and I want specific pictures with these properties. So with a PF query, you create a new one for pictures. Then you say, I actually want pictures that are associated with the user that's logged in. So only my photos, that's what I want to get back. And actually, I only want those that were created in the last week. So you can see there are two constraints: equal to the current user, greater than a week ago. And you just call find objects in background. That's going to talk to parse, get the objects, and return everything that matches. And this will return a block, or this actually takes a block as a parameter. So one aside about blocks, if you're not familiar with them, they're basically closures where you can specify code to be run later in this example. So you want the data to, you want the query to go out to parse, and when that data is available, then run this code without locking your UI. So in this case, if there's no error, I'm going to get an NS array of all the objects that match. But it's not just querying for data. As I mentioned earlier, you want your app to be to work while offline. So something that you can do when you're querying for objects, you can specify a cache policy. That cache policy will tell us, in this case, cache the network, will tell parse, return all the objects that you have available locally first, and then hit the network. What that means is that if you have a table view of objects, when you load that app and there's no internet connection, it will still show the old list of results. As soon as there's a network connection, it's going to refresh with those new objects. So it makes for a very smooth experience. And there's many other cache policies that you might want to use depending on your use case. So how do you actually relate objects between each other? Like which comment goes on which photo, which user is following which user? There's various ways of doing that in parse, and you actually already saw one of those, which is the one-to-one and one-to-many relation. So if you wanted to associate a comment with a user, you just basically pass that PF object, in this case PF user, as a value on the key, and it's going to create a link. And it's not just creating a foreign key for you. It's actually storing a pointer to the object, so you can just get it out in the same way, and it's available there for you to use. Now, the following relation is a little bit more complicated, because you have people following users, they might not be following back, so it's a many-to-many relation. If you were to implement this relation in your own backend, you will probably try creating a join table between two classes. But we don't want you to be creating these tables every time you create these relations. So we actually have a PF relation object. Basically, you say, I want to create a relation in this key, in the following key, which will basically hold a list of other users. I can just add users to that relation and save the user object, and that's going to take care of creating that join table for you. The great thing about using this approach is that it's not actually storing those objects on the parent object. So when you query for the parent, you're not getting additional data that you don't need. You actually use a query over that relation, which allows you to still be to add constraints over that relation and get them back. So this is one of my favorite features of Parse, which is actually sending push notifications to your users. They are great for engagement. They keep your users coming back using your app. And one way of doing it very easily is to basically use channels. So you can say, I'm targeting this specific group of people. In this case, mobile DevCon attendees. So if I subscribe the user to that channel, if I want to send a message to everybody in that group, I just send a push to that channel, and everybody will get it. And that's great, but it's a little unwieldy to add more people to that channel. So one thing you might want to try is actually using a query to target users specifically. So PF installation is basically an object that is created whenever a user installs your app. And a PF installation is a subclass of PF object. So you can set any data on it in order to help you identify that device. So in this case, I'm going to link each device with the user that's logged in. And that will allow me to query for those users specifically. In order to send a push notification to that subset of users, I basically create that query over installations, saying I want the owner key to match this other query, which in this case is a geo query, which is saying target people that are within 1 kilometer of this current location. And you just push to that query. It's not locked down to a specific channel. It's just getting all the objects that match that query and sending a push to them. So we covered displaying data, managing relations, and push notifications. Like I mentioned earlier, these are iOS examples, but we have native SDKs for all the major platforms, as well as a REST API. So don't worry, if you're targeting Android, it works just the same using the standard Android coding conventions. So the final thing I want to talk about today is Cloud Code. So Cloud Code is basically JavaScript in the cloud. Why is this important? It actually allows you to offload operations from the client side to the server. You can do validations, maybe data you don't want to repeat every time in the client. So for example, if I want to, let's say I want to calculate how many likes I get in my Instagram app on average, I can create a custom function called average likes, where I basically, and as I mentioned, this is JavaScript. So you're seeing the JavaScript SDK. I can query for all the photos that are owned by the user that made that call find, that's going to get me an array of all those objects that match. Then I just get the likes property, add them up, and return that calculation to the client. What we're doing here, instead of fetching all the objects, downloading them to the client, adding up everything client-side, and displaying it, I'm doing everything on the cloud, and I'm only transmitting that result. So it's great for mobile applications over cellular networks. But that's not just it. We don't just have custom functions. We can also trigger custom operations to happen when objects are saved, so you can automate processes in your app. So for example, when people are adding comments to my app, I want to make sure that that text that they added to the comment is actually short enough to be shared on Twitter. So I can actually implement validations on the cloud in this manner. I get the value for that comment. I check if it's over 140 characters. And if it is, I truncate it. I set it as a new value for that key, and then response.success. That's going to tell Parse, I made all the changes I was going to make, proceed with saving this object. If I actually wanted to reject all comments that are over 140, instead of changing that data, I could just call response.error, and it's going to block that save. So that's before objects are saved. You can also perform operations after objects are saved. And I like to use this method to automate sending push notifications whenever the user interacts with your app. So let's say I wanted to send a push notification to the owner of a photo whenever someone adds a comment on their photo. So basically, I will get the value of that comment. I create a push query that targets just the installation for the device of the owner of that photo, and send a push to any device that matches that query. And automatically, it's going to send push notifications for comments. So something else that you might use Cloud Code for is to integrate with third-party APIs. So let's say instead of sending push notifications, you want to send emails or text messages. We have actually partnered with many companies that allow you to do that. Or you can even process payments, credit cards, on the cloud using Stripe. If you want to use a third-party API that's not already available as a built-in module, you can use HTTP request to talk to any URL. So you can basically talk to any API. So with that out of the way, going back to Instagram, so I've been telling you how you could, in theory, create that with Instagram, how you could, in theory, recreate Instagram using parse. But I'm not just saying it's theory, we actually did it. You can go to anypic.org. It's an open source app that we built, and it's very similar to how Instagram works. So check it out. The code is available on GitHub. And there's a great tutorial that you can follow to help you build your own version of anypic. And I invite you to check out all the tutorials that we have up at parse.com/tutorials. And I'm looking forward to seeing what you guys build on top of parse. So we have some time for questions, if anybody.
Hi, my name's Lewis. I'm from Forward Labs. I'm quite interested in how PARS works for on-device, saving things on the device before you upload to the cloud. So say in the Instagram example, if I take a picture, but my phone doesn't have internet connectivity, is there some way to push it to PARS and then have it in the background, upload it at a later stage or something like that?
Yes, definitely. So the examples I used today, they were all saved in background, so they try to save immediately. There's actually another method called save eventually, and it literally does that. It will try to save immediately. If it cannot, it will serialize the data and keep trying again, and that will persist even if the application is closed or the device is turned off.
Hi, Richard Brindley. One of the things that one would do if one was developing a back-end, though, would be to put in place quite often back-end systems processing, which might look at objects that particular users have put up to the system and draw some conclusions about how close objects are to one another. So somebody might like curry, and somebody might like movies starring Arnold Schwarzenegger, right? So you might want to push some data to someone who likes movies about Arnold Schwarzenegger and curry, right? Are there APIs in PARS that allow you to do that kind of contextual matching at the back end so that you can create those queries?
Right. So there's some ways you can build that out. So when you query for objects, you can say, give me everything that matches curry. Or you can say, give me anything that's within this radius of this location. You can combine both of them and get a very specific query for curry around here. But you can also combine queries with each other. So you could say, first get me all the users that have similar interests to me, and then find all the users in that list that are within this specific radius. So yeah, I mean, it can be implemented. you can do it in the client side, or you can do it on the cloud. Yeah. Yeah, the full SDK is available in JavaScript, so you can do everything in cloud code as well.
Hi, I'm Arish from Branded. We've been using Parse for a long time. Really like it. I think the only drawback we've seen so far is that when we need to do big database updates, like edit, we end up having to do an API call for every edit. And you guys charge by API call, right?
Right.
So can we expect any kind of, is there like a paid version where we don't get charged, or like it's easier to do updates? Like what's the difference between the paid version and the free version?
The free version and the paid version, they basically work the same at the API level. The paid version might have some additional features on the website, but all the features are available via the SDKs. As for saving and using API requests, anytime you hit our servers, that's an API request. So, I mean, we have to calculate those.
Yeah, but it would be simple for me to, like, I can upload classes, but I can't update classes.
Right, so you can import data into a non-existent class.
Yeah, exactly. That's the problem. When I need to update my user table, for example, then
I mean, it's available via the REST API and the JavaScript SDK, but we need to actually calculate how many times you're hitting our servers.
Okay. I mean, it would be nice if we could just upload a CSV and then you guys handle all of that stuff on your side, so we're not using bandwidth to do it.
Hi. Hello. I'm looking at Parse for game development and Unity in particular. And it was recently announced that Facebook and Unity are sort of getting closer together. And since Parse has just been acquired by Facebook recently, are there any plans for integration into Unity? Because currently it's a native SDK, isn't it? So is there some sort of plans for a plugin or to make the process more integrated, basically?
So, like you mentioned, these are very recent news. So I believe we have no answer for that at this time. But I invite you to read our blog, and we will make any announcements as there are any developments. Okay.
Hi, Grant from Session Digital and Envika. I've used your library in quite a lot of apps at like hack days and things like that, and I've actually refactored some of my apps into using Parse. One of the things that I'm struggling with is actually using it on my web, because obviously I want to try and do mobile and do web at the same time. So I think not having like a PHP SDK is kind of holding me back on that. Do you think you guys will be investing more in PHP as part of the stack?
So you're correct. Right now we don't have a PHP native SDK, but there's a REST API. So basically you can talk to Parse with any language. If we make a PHP SDK, we will announce it when it's ready. We don't usually talk about features that are not available yet.
Thanks.
But we listen to all feedback, so get in touch with us. That's based on your interest, that's what tells us what to work on next. Any other questions? Yeah, the gentleman over here.
Yeah, hi, I'm Dan from Badoo. What do you recommend would be a good strategy for integrating Parse with core data? Do you provide like a incremental store set of classes, or is it sort of a roll your own sort of strategy?
Yeah, so right now we don't have a specific core data integration, but that's something that many users have been asking for. And we've been working hard looking at that problem in order to have like a very good solution for that. Keep in mind that we are not just iOS. We handle all the platforms, so we have to make sure that whatever we provide works just as well for all the platforms. I know that some users basically use an incremental store to keep parse objects and core data in sync. but you need to manage that integration. But we're aware of that, and we are looking at a way of solving that. Anyone else? Okay, so I'll be having office hours later, so feel free to reach out. And thank you.
Okay, Hector, thank you very much. Guys, we're going to break for 10 minutes, and when we get back, we have our app development panel. So get a drink, relax, and we'll see you in 10 minutes. Thank you.